So today we have taken this question, okay, where two masses are given to you, one kept upon another, okay. One is of 4 kg, another is of 1 kg, right? So the question is that the friction coefficient between the two blocks, between these two blocks, the coefficient of friction is given to you as mu. So here we have mu as the coefficient of friction, right? Here it's mu. Now this is 1 kg mass, this is 4 kg mass, right? And the horizontal plane is considered as smooth, right? This plane is smooth, so there is no mu acting over here, okay? Only between the two masses mu is acting over here, right? And if the system is slightly displaced, that means from the equilibrium this entire system is slightly displaced and released, it will execute SHM because there is a spring associated to it, and the spring constant of this spring is given to you as K, right? The maximum amplitude, we need to find the maximum amplitude. If the upper block does not, the amplitude we need to find if the upper block, this one 1 kg block, does not slip relative to lower block, right? So into this question we need to understand how to move forward, okay. So students, you know this force acting by when a spring is associated force will be F equal to minus kx, and let us assume this both the masses together, okay. The total mass into this case will be equal to 4 plus 1, which is equal to 5 kg, right? For a small amplitude, the two blocks oscillate together. That means from the mean position, they will go over here, then return back, then go over here, then return back, like this. This oscillation is happening, right? This entire system is displaced towards left, coming to mean position, then going towards right, then coming to mean position, right? So SHM will be executed over here due to the presence of this spring. Now the angular frequency for the entire block of 5 kg 4 plus 1 can be given as angular frequency, let us say omega, can be given as root over k by m. So k is the spring constant and m is the mass, which is equal to 5 kg. So this is equal to angular frequency of this SHM, right? Now the acceleration of blocks, this acceleration of blocks for this entire blocks at a displacement x from mean position. So we can say that acceleration A using the formula minus omega square into x. If x is the displacement here, x is the displacement, x is the displacement over here, right? Now acceleration will be minus omega square x, right? Now what is omega? We already calculated this angular frequency omega here, right? So we can say that this acceleration A as equal to minus omega square. Omega is k by 5. It will be minus root over of k by 5 whole square multiplied with x. This will be giving you minus k by 5x as the value of acceleration of this system. Now, the resultant force on the upper block is 1 kg, will be equal to F equal to ma. You know that? So, the force on 1 kg, since A is known to you and mass is 1 kg, m into A, which is equal to 1 into, put the value of A, k by 5 into x. So I'm taking it resultant so that I'm ignoring the negative sign. So the force on 1 kg mass will be equal to this much, kx by 5, right? Now this force is provided by friction of lower block, because this is not connected directly. 1 kg block is not connected directly to the string or through the spring, right? So this is provided by the maximum force of friction. Okay, so the force is provided by the friction of lower block. And what is the friction of lower block? You can see from here, because the coefficient of friction between the two blocks is mu, right? And what will be the equivalent frictional force on this block? F equal to mu times n, right? So frictional force for on this will be, let me write, frictional force will be equal to, this force is provided by friction of the lower block, that is due to this mu, right? And that is equal to 1 into k by 5x, right? This is equated with this force. So, and the frictional force is basically, this is equal to mu times n, right? Where n is the normal reaction. So this is this can be written as, n can be written as m into g. So 1 into g mu into 1 into g, right? Equating with this maximum force of friction for the SHM of upper block will be 1 into k by 5 into x. So x is the normal displacement which we have taken a small. For maximum displacement, x will be equal to a, that is the amplitude, maximum one, right? Then just in place of here x, just write a. So we have this equation with us. 1 into k by 5a equal to mu times n. That is the frictional force. Let me squeeze a little. Right? I hope is it I hope this is visible to you. Let me zoom. Yeah. So from here, what is the maximum amplitude we are going to find? This was the question. What was the maximum amplitude? So the maximum amplitude is A. So from here we can write mu g into 5 by k, 5 going to the LHS, k coming to the LHS into the numerator and denominator respectively is equal to A. So this will give you the value 5 times mu times g divided by k, the coefficient of friction, the coefficient of spring constant. 5 mu z by k is the value of A. So the question was that what is the maximum amplitude? Okay, so the maximum amplitude is 5 times mu times g by k, when the coefficient of friction mu is acting between the two blocks only, right? This is the maximum amplitude, right? Maximum amplitude is 5 times mu g by k. And this is our answer, students. If you find it useful, you can just like and be connected. Take care. Bye bye.